Hello, chemistry students. This short video is going to talk about an amazing discovery by scientists that every element in the universe gives off its own specific wavelengths of light. And we can use that information to look for what color light different elements give off. And we can say, hey, we know exactly what element that is. It's kind of like the DNA test for atoms. And let me explain in a brief diagram here how that works. The example I'm going to do is hydrogen. Hey, it's the simplest atom out there, and one proton, one electron. Yeah, let's use a simple example to tell a complicated story. Here it goes. Here's our proton, and in a normal atom of hydrogen, just hanging around, being all normal, its electron is going to be its lowest energy state. All right, if I'm at home, after a long day, maybe in my low energy state, I'm on the couch watching some fun TV programs, having a snack, low energy. All right. Well, there it is. But if you were to take this hydrogen atom and add some energy to it, maybe you heat it up a whole lot or you zap it with some high energy light or something like that, this electron can go from its ground state up to some of these other orbitals. There'll be higher energy states, and all that stuff you learned about 1s2 and 2s2, 2p6, that's what these drawings are, different electron orbitals. All right, so take that electron, give it some energy, give it a little kick, and hey, this guy can jump up maybe to here. So let's have that one go up to here for a little bit. All right, so far so good, that makes sense. And well, the electron in this excited state won't stay there for long. If it can get back to its comfort zone, its ground state, low energy state, it's going to. And here's the really important part to know. As this electron jumps back down to its ground energy state, it has to release some energy. And in doing so, it can only release energy in the form of a photon, of light, of a specific wavelength. And here it is, when this makes the jump, whoop, back over to here, it has to get rid of that energy. Here's that wavelength, that photon is flying out there, and hey, we can measure that. There's that light that gets emitted. All right, and hey, that wasn't a very big hop, and I used red marker on purpose. A red light, kind of lower energy light. What happens if you gave this an extra karate chop and knocked it up to an even higher energy state? Out there to be the 2p orbital for a bit. Well, hey, maybe when it jumps from here back down to here and makes this jump, it's releasing energy. But hey, it's jumping from a higher cliff, has more energy to give as it gets closer and closer to that nucleus. Bigger jump, more energy, that's a higher energy light. There's our green light wave that gets kicked out. And one more example for fun, I got the blue marker, blue light getting towards ultraviolet, higher energy yet. If an electron jumps maybe out to here or here to some other specific orbital, when it makes the jump, oh, I'm sorry, not up to the nucleus, and down to the 1s shell, hey, it's going to send out even higher energy light yet. And, well, these specific wavelengths can be measured, and if scientists look for them, they can say, hey, I know hydrogen is there, because it only gives off light of these specific wavelengths. And in class, you'll see this with your own eyes, wearing some crazy 3D glasses. When we excite hydrogen atoms with high voltage electricity, it'll emit different wavelengths, and you'll see them. So hey, it's one thing to hear a teacher talk about what hydrogen can do, but why I love science so much, and why I hope you like chemistry too, is that you'll be able to see this for yourself.